Friends, welcome to this video session. The topic we are going to study in this session is structure of atom. We have seen that the existence of different substances is due to the atoms from which they are made. But why does the atom of one element differ from the atoms of another element? And are atoms really undivided? We will find the answers of these questions in some upcoming videos. Let us do an activity to know the nature of particles in matter. Comb dry hair. Now, move this comb close to the small pieces of paper. What do you see? Yes, the comb attracts small pieces of paper. We conclude that on rubbing two objects together, they become electrically charged. Where does this charge come from? This question can be answered by knowing that an atom is divisible and consists of charged particles. By the 19th century, scientists had discovered that an atom is not an ordinary and indivisible particle, but it contains at least one subatomic particle, that is, electron. In 1886, E. Goldstein discovered another subatomic particle whose charge was equal to, but opposite to the charge of the electron, and the mass was approximately 2000 times more than the electron. These particles were named proton. Now, the biggest question was how these particles structure the atom. To understand this, many scientists presented different types of models. Let us first study Thomson's atomic model. Thomson presented a model related to the structure of an atom that was like a watermelon. According to this, the positive charge in the atom is spread all over, like the red edible part of the watermelon, while the electrons are studded in the positively charged sphere, like the seeds in the watermelon. Thomson proposed that 1. An atom consists of a positively charged sphere and the electrons are embedded in it. 2. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Although Thomson's model explained that atoms are electrically neutral, the results of experiments carried out by other scientists could not be explained by this model. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. 1. He selected a gold foil because he wanted as thin a layer as possible. This gold foil was about 1000 atoms thick. 2. Alpha particles are doubly charged helium ions, and they are positively charged. And since they have a mass of 4U, the fast-moving alpha particles have a considerable amount of energy. 3. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. Was the result of alpha particle scattering experiment as expected by Rutherford? No. Rather, the alpha particle scattering experiment gave totally unexpected results. 1. Most of the fast-moving alpha particles passed straight through the gold foil. 2. Some of the alpha particles were deflected by the foil by small angles. 3. Surprisingly, 1 out of every 12,000 particles appeared to rebound. Rutherford derived the following results based on an alpha particle scattering experiment. 1. Most of the space inside the atom is empty because most of the alpha particles passed through the gold foil without getting deflected. 2. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. 3. A very small fraction of alpha particles were deflected by 180 degrees, indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. 4. From the data, he also calculated that the radius of the nucleus is about 10 raised to 5 times less than the radius of the atom. Based on his experiments, Rutherford presented the nuclear model of the atom. 1. There is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. 2. The electrons revolve around the nucleus in circular paths. 3. The size of the nucleus is very small as compared to the size of the atom. Were there any drawbacks in Rutherford's model? Yes. The orbital revolution of the electron is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and finally fall into the nucleus. And if this were so, the atom should be highly unstable, and hence matter would not exist in the form that we know. We know that atoms are quite stable. In order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward the following postulates about the model of an atom. 1. Only certain special orbits, known as discrete orbits of electrons, are allowed inside the atom. 2. While revolving in discrete orbits, the electrons do not radiate energy. These orbits or shells are represented by the letters K, L, M, N, or the numbers n is equal to 1, 2, 3, 4, and so on. Do only protons and electrons exist in an atom? In 1932, J. Chadwick discovered another subatomic particle which had no charge and a mass nearly equal to that of a proton. It was eventually named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen. In general, a neutron is represented as N. The mass of an atom is therefore given by the sum of the mass of protons and the mass of neutrons present in the nucleus. In this video, we studied the structure of atom. In the next video, we will learn about the distribution of electrons in orbits.